So, sorry, my name is Javi. I've been working at Deel as senior data analyst. Prior to that, I've been working as data analyst as well in the last mile delivery industry, working with companies such as Glovo. And yeah, I've been doing pretty much data analytics engineering stuff. So today, I'm gonna talk about data observability. And I wanna start by asking you, how many of you work on the data field? No matter if it's data analyst, okay, so it seems like almost everyone. Perfect. Working as data analyst? Only data analyst? Okay, perfect. Data engineers or analytics engineers? Okay. Business analyst? Okay, perfect. Anything else that is not on that? Okay, great. So it seems we have a very interesting audience today. And the good thing is, I guess all of you will learn something today. So I'm going to start by sharing something that probably those of you that work on the data industry knows this is a wishful thinking. Right now, there is no single company on the universe that has no single problems on the pipeline. Normally, things look more like this. Huge loading times, errors everywhere, timeout issues, fields not found in the database, tables that hasn't been transported correctly. And for those that work as data analysts or business analysts, you know that how frustrating it is to explain to business stakeholders why things have been breaking and when things will be business as usual again. In order to explain how to apply data observability techniques, I'm going to start by giving you a little bit of context on how we end up on this mass situation. As you know, over the last few years, companies have been putting data as the cornerstone on the companies, moving from instant decisions to data-driven decisions. So we've been collecting data from many different sources. We've been also getting more and more data, not only because of the sources we use, but also storing a lot of quantity. And that's probably made the reason why we are here, talking about observability. Data observability is not only about monitoring that the dashboard is refreshed or that your tracker is currently updated. Data observability is really looking into proactively detect anomalies that is happening within your process of transforming the data, so you can easily detect whenever this happens and take action. So, I'm going to start by putting a simple example so you guys understand better what data observability, how data observability works. Imagine you're running a logistic business, such as Amazon. Amazon could have hundreds of thousands of cargos moving all around the cities, delivering packages to the clients. And probably the business will be asking some questions on operations, such as, is the cargo moving? Are they actually moving at the right speed, so we deliver packages to our clients on time? And also, is the cargo containing all the packages from the clients? And what if we have a change on the route? How those changes would affect to the deliveries? Well, let me tell you something. On data, we also want to have an answer for those questions. We want to understand whether the data pipeline is running, and if it's running at the right speed, so we commit to the SLAs. Most of you know that companies are now creating what we call the data contracts. Data contracts is, let's say, an agreement between teams to deliver data on time so they can use for building some other reports, such as a PRL for finance. So we want to ensure that the data is committed within the SLA. Also, we want to understand if we are losing fields within the models, or if any of the sources make some changes, such as deprecating a field, how this is going to impact on the upstream models. Now, I'm going to start by putting this slide about modern data stack, because I want to explain to you how companies using a modern data stack can solve problems on data quality using observability techniques. You're probably familiarized with this kind of a slide, so I'll be fast here. You know, we have quite a lot of different sources. We connect to our warehouse using a loading tool such as Python. And everything within the warehouse used to be transported or synchronized with tools such as Airflow or dbt to finally be consumed on a consuming phase in BI tools such as Looker, Tableau, Power BI, or even trackers and Google Sheets. Today we'll be focused primarily on everything that is happening within the warehouse. There are many different definitions in order to say the different data layers for the transformation, but there are mainly common three ones: source, intermediates, and analytics. And let me put you some numbers here because this is gonna be impressive. Right now, working at Deel, only 4 years old company, we have more than 2,500 source models. That means we have close to have more source models than companies that employees at the company. So having only 40 people in the data team is completely possible to be aware of any changes that are applicable here to the source models. While they could seem very simple, some of them, because we used to, let's say, rename some of the fields, make some cleanup exercise, maybe draw some police or simple filtering, having more than 2,000 fields, more than 2,000 models, makes it impossible to track all of them. And that's why observability is so important for us. But it is not only about the models, the source models, it is also about the transformation. We have more than 1,200 transformation models. Those models has been built from scratch, and they seems to be a little bit more complex than the source models, where we have quite a few CTEs, with functions, joins from different sources, or even from other intermediate bodies that has more complexity. That said, this is very useful for creating calculations, applying logic. Working?
No.
No, it's not working. No. No. This one. So yeah, transformation models, they're more complex than source models, and they use to get some calculations closely and enriching the models for the data lake. And lastly, we are exposing more than 500 models to the BI tool. In Looker, for instance, that is the visualization tool we use, you can identify more than 500 models, and that's amazing. Those models seem to be pretty straightforward because they use to initially the different fields we created primarily on the intermediate models, but it's still having more than 500 is a little bit much. And it's not working again. I can try with both. Maybe you can hear me if I just speak a little bit. Yeah, let's do it like this. So, I was saying, analytics models seems to be a little bit easier than intermediate models. But do you remember I said we have more than 500 models? Now imagine having this data limits for 500 times. There are more than 200 models involved in order to get what we call the compliance documents model. As you can see here, this is definitely not simple, and this is definitely not scalable, because if this is the limit we have for one single model, imagine what we have for 500. So definitely observability is needed here. And you might be asking, what is the best solution here? Well, the disclaimer is, there is no one-size-fits-all solution, unfortunately, because it depends on the business maturity, it depends on how many people are working on the data that can support on observability, and also it depends on your own data stack. But I wanted to give you 3 useful tips that, independently of your business maturity, independently of your workforce, and independently of your data stack, can be very useful and applicable to your use cases. I'm going to start with the first one. Enabling the right tools. Well, data observability is useful not only for Deel, but also for many companies in the world. And as a consequence, there are some interesting tools in the market that you can use to leverage your observability techniques. Some of those tools could be Datadog or Dynatrace. They are commonly known as application performance monitoring tools. And they are very useful to determine what is your failure ratio. So out of all the transformations I'm running on a daily basis, what percentage are failing? Or what is the average execution time? Like how much those transformations are taking in order to load them up. Another one that I really like is PyReader. For those that are using dbt within your text data stack, PyReader allows you to identify what is the impact of the changes you are applying on your pull request before submitting and merging your pull request. So instead of reactively identifying the issues and fix them on a new pull request, with this tool, you can directly identify what is going to be the models and fields affected. So you change this all at once, and you avoid issues to the business users. This is an open source, by the way, so I really recommend you to reach it out. Also, you can try Latitude, as Cesar mentioned. Latitude is very useful for data analysis purposes, and they recently released a new feature called Profiler. That by simply connecting your source, no matter if it's a CSV file or if it's a table in your warehouse, you can get some details about the quality of your fields, such as the state, or even identify the percentage of null values. So we can identify that, for instance, on volumes volume, we have 45% of the records with null values. So you may be interested to run out a further investigation. Second point, keep your house clean. During the past few years, as I mentioned at the beginning, all the companies have been storing quite a lot of data. And probably most of the things that have been done 3 years ago are legacy and are no longer useful for anyone. So I think it's a critical moment for all of us to really look into what is in use, what is not in use, and get rid of everything that we are not actually using. By following 3 simple steps, you can do that. The first one, for those that are using modern warehouse cloud systems, such as Snowflake, there are predefined history models you can use in order to identify which fields and tables within those fields, which tables and which fields within those tables are not in use for the past, imagine, 3 months. So you can just, identify them, talk with the owner of those models, and never mind, you can get rid of them. So you gain speed, you improve your efficiency and reduce the workload on your systems. Here's an example, in my case, from an analysis I ran a couple of weeks ago, where I found that 23% of the fields within our warehouse hasn't been used for the past 90 days. 23% of the fields. That means like 1 out of 4 fields hasn't been used for the past 3 months. It's like crazy that we are storing data that nobody is using. So this is costing money. And here's an example of the history model on Snowflake, where we can identify for every table and every column within the table how many times this field has been used. Lastly, I think it's very important to talk about quality checks. On an ideal world, checks wouldn't be necessary anymore. But the reality is that as humans, we don't create perfect models, and also sources could have some issues as well. So it is super important to define quality checks within your models to ensure you get a proper quality among the transformations. 3 simple steps as well. The first one is start with generic tests. For instance, on dbt you have some predefined logic that you can use, such as unique, null, or even relationship filters. You can specify to check the quality of those fields. So you no longer need to create complex things, but you can, let's say, leverage what is actually useful for you. Also, it's super important to define the criticality. Let's say that you're putting tests on a table called orders that are coming from Shopify. And this table contains 1 column that is value. So this value is probably the cost of the order. The cost shouldn't be negative anymore. And defining a test over this column probably is something very critical for you, because you don't want to set negative values over a value that is a cost. While maybe you have another Boolean fields that are defining whether the order was too big. That doesn't matter at all if this value, let's say column is not filled. because this is not that critical for the business, so you can specify a lower criticality over this one. Also, it's super important to integrate all those quality checks into a checks system, because it doesn't make sense to just, let's say, leverage all the checks and then don't follow them up. So I really recommend you to use a Slack, Gmail, whatever communication tool you use in the company to get a proper communication channel where you, let's say, get all those data points and then understand whenever there is a check that has failed. As an example here, I can show you a GML file or a table called contracts. This table has a contract ID granularity. Of course, contract ID should be unique because it's the maximum level of granularity. And as you can see here, I'm specifying that this field can be null and should be unique. So we ensure a proper quality over this table. Also, I'm specifying all the type tests such as accepted values over the status of the contract, where only pending, ongoing, completed, and cancelled are the appropriate values over this table. Also, we can stamp for other filters and checks, such as relationships. Imagine we have a column called user ID. Okay, so the user ID needs to be within the user table. Otherwise, I want to have a test alert that tells me something is going on this column. Also, you can use more advanced tests, such as this one, for getting negative values, where we are specifying the severity of the check. In this case, is warn, which means warning, so it's not going to be high criticality.
Okay.
Some examples about how those quality checks looks like on Airflow. In this case, those are messages that we receive from Airflow in our Slack channel. So as soon as those messages are sent, we are aware of them, and then we can proactively look into what's going on within the logs. And I think that's pretty much it from the fixed perspective. I'm gonna finish with one more thing for those of you working as data analysts. Some recommendations that have been working very well for me in the past, and I think it's worth mentioning. The first one, I really encourage you to be curious. I know that for a data analyst, it doesn't make sense to understand all the things that are going on within the transformation layer, because it's not the primary responsibility. But it is true that if you have those competencies, at least on a couple models you really use on a daily basis, you will get an upskill on knowledge about those models, and you can identify probably some weird things and understand why they are happening. So I think it's going to be very interesting for all of you working as data analysts as well. And the other thing is really about ensuring we have a proper communication channels between data engineers or backend engineers with data analysts. I've seen in the past companies where the data engineer and data analyst didn't meet each other. And I think this is an issue because data analyst is probably the bottleneck for the business people to get a lot of feedback from them that can be reported directly to the backend engineers in order to make some improvements on the data pipeline. And also in the opposite direction, for data engineers, whenever they make changes on the transformation, let's say for instance you are deprecating one field, as soon as the data analyst is aware of it, this person can double check that non-dashboard near tracker is affected by those changes. So we minimize the impact in our business stakeholders. So that's pretty much for today's presentation. We'll have some Q&A time today. Okay.
Yeah, so if you have questions, please stand up and speak loudly so we can all hear you, and that's it.
So, one from News Corp, data governance analyst. There are two questions from my side. The first thing is, when you talk about observability, what's your personal opinion on those observability tools like Monte Carlo, Soda, so on? Instead of we do the work by ourselves and also use some open source tools. And the second thing is, as you already mapped out the lineage, how can you ensure, for example, when we have the customer, they want to opt out their data, what's the best practice would be based on your experience?
So the second one is about how you, can you say that again, about the use?
Yeah, customer data is PII, personal identifiable information. So when, based on the GDPR, they have the right to choose to opt out from our database. So we are not, if they choose so, we are not allowed to have their data in any way in our database anymore. So from, based on your experience, what's the best practice for this kind of practice?
Okay, thanks so much for the questions. I'm gonna start by answering the second one. So I think PII information, like private information such as, for instance, now we were talking about contracts, let's say a salary related to a contract, is very important, and privileged data that we carefully consider. When it comes to, let's say, playing around with the data of the users that has opted out, but decided not to, let's say, use this data to make decisions, we used to have a model that contains at a user level, or in this case at the contract level, whether the let's say user have decided to opt out for communications. So in that case, we used to consider this Boolean field that determines whether the user is opting out or not in order to, let's say, embed this data within the inputs. That would be the my answer.
Second.
Can you say that again for the first one? Sorry.
What's your personal opinion on those?
I'm Monte Carlo, right?
Yeah, Monte Carlo also that those data observability tools.
Yeah, I think both could be working very well. I think sort of primarily on small and medium-sized companies because of the integration you could have with the, let's say, data stack you have on the company. Maybe when you're having a larger data stack in a complex one, it would be more interesting to just, let's say, leverage existing tools that you don't, let's say, require a software engineer or a data scientist to run multi-parallel analysis and get more technical knowledge in order to get an output. The good thing about tools such as Datadog or Dynatrace or PyReader is that you don't need that hard technical skills to get into a conclusion. So I would probably leverage those tools better than Monte Carlo in the sense of faster action and simplicity.
Thank you.
More questions?
I think you raised the hand first.
So have you been able to take some of your own advice and reduce some of the 2,500 data volumes that they have at you?
Thanks for the question. I think it's a good one. Right now we are in the middle of these conversations because one thing that happens, and you probably agree with me, when you start looking into things that hasn't been used for a while, it is hard to identify who's the owner of those models. So it's not that easy to say, okay, let's disconnect this, and this is probably affecting some intermediate models that are in use. So it is more about understanding the criticality of removing those models. Right now, we started from the other way, like how many of our analytics models can be removed and how many of our intermediate models can be removed. So then we start from the bottom to the top. Thanks.
Javi, if you can repeat the question after they ask it, that way we can record it with the mic.
He was asking, by the way, how we are working on detecting and removing those source models that hasn't been used for a while. And the answer was actually that we are taking the other way around. So we are identifying those analytics models that hasn't been used, and then identifying back what are the intermediate models and source models that are not used. But of course, it is a complex one because it is hard to identify sometimes the owner of things that hasn't been used for a while.
At Deel, do you have any process or tools in place to enforce the data contract, so to make sure that no upstream changes affect the downstream models, with what things you do in practice to avoid that?
Okay, so the question here is, at Deel, how are we facing changes that are happening on the downstream models, such as, for instance, the source models? How are we preventing issues to happen on the analytics layer? I guess that's probably the answer. So, that's the question. So the answer, I think, is having proper communication channels. I think that's the key. Right now, we used to have separated teams between the data engineers and the data analysts. Now we have combined them all together. So right now, as soon as they, let's say, have some deprecated fields or changes on the sources, we are aware. So we can proactively identify, following the lineage, what things are gonna break if they submit a pull request. So yeah, I think it's collaboration between both people that are owning the source models and the people that are owning the analytics models. Anyone else?
More questions? No? I saw a few other hands. There.
Okay.
Just for curiosity, maybe it's not up to you to decide, but why you choose that tool, for example, Snowflake and Looker? Have you Looker as a Google tool? Why maybe, for example, you choose Require, for example, instead of Snowflake, or maybe Tableau instead of Looker? I don't know if it's up to you, but it's my question.
Okay, thanks for the question. The question is back on the data set. Here, so the question is why we decided to use Snowflake and Looker. So yeah, that's a very good question. Unfortunately, I didn't decide it. I just came when the things were built. What I can tell you after working with Looker for quite a while, for quite a long time, is it used to be a very cool tool for large companies to create things, let's say, separated on chips. So it is a very powerful thing to combine everything on a single place and limit just a few developers to edit what we call the LookML, that is, let's say, the backend on Looker. And I think this tool has a lot of limitations, such as Tableau and Power BI. There is no perfect BI tool, it depends on your use cases. But I would say that for large companies, I must suggest Looker as the BI tool because of the potential it has for connecting with a warehouse and loading things fast.
Okay.
Yeah, I had a question, which was which Looker, but then you said Looker ML, and I got which Looker you're using, because it's Looker and Looker Studio, right? And
yeah.
So it's a little bit confusing, but you answered it.
So yeah, the question here is, I was mentioning about LookML and what's your name?
Ando.
Ando was asking about what's the difference between Looker, LookML, and Looker Studio.
No, I wasn't sure which Looker you were referring to.
Perfect. So it was primarily Looker. Okay, let's go. Okay, guys, any other question? Or?
No? No one? Okay, perfect. So, thank you so much, Javi. So I hope you enjoyed the talk. I for sure did. We have pizzas coming in a second, so while you wait for them, make sure to get some drinks there at the bar, do some networking, and you'll be able to smell the pizzas when you come. Thank you so much for coming. We'll do another event next month and every month after that, so make sure you join the meetup group to be notified of the next one. And that's it. Thank you so much for coming.